Hello, everyone. This is Rajesh Pichaimani, and I'm a solutions architect at Amazon Web Services. In this session, we are going to start with a series on the topic of open tables on AWS workshop. We will start with what the workshop is about, what it entails, and what we are going to cover in this section. We'll switch to the console to do a demo walkthrough and finally conclude with references. So let's get this started here with this tutorial. So this is the open table formats on AWS. To access this workshop, use this QR code as highlighted in this slide. Because this is content of this workshop is going to be big, I'm going to break it down into 3 sections. The first one, this session, we will cover the base functionalities in EMR serverless and Glue. In the second part, we are going to cover the advanced functionalities again with the EMR and Glue. Finally, we'll conclude with the third part, focusing on Athena for base, Athena for advanced, and how we can use Athena for the consumption part. So let's get this started with the console. Going to switch to the console here. This is a workshop that I was referring in the slide. Just to give a brief overview of the open table format. As you might know by now, the modern data lake architecture has been providing a lot of benefits in the current architecture, in providing the cost advantage as well as flexibility and scalability as data arise from more and more data sources and at a different variety, velocity, etc. However, there are certain areas where it still lacks some benefits, and the database like capabilities are one such thing to ensure that the data consistency to be maintained across multiple concurrent writers and readers. Meaning, as more and more application trying to access the data, we need to ensure that the data is consistent, and also it is fail-proof as multiple writers operations happen, and that should not corrupt the data as well, right? So these are the different deficiencies that the open table format tries to overcome. And here's a quick, very high-level list that the benefits that open table format brings. Transaction support, providing ACID guarantees, schema evolution that we will be walking over in just a second here, and so on and so forth. Okay. As mentioned here, in terms of the prerequisites, we will have to start with the EMR Studio as outlined in the workshop. In the console, when you type EMR, you will land up in this page. Click on Studios, create Studio. Think of this studio as an integrated development environment for big data processing and the data processing needs, right? And so we are setting up this environment right now. The workshop highlights that we edit this settings to point to Studio 1, pointing to the S3 location for the workshop storage. And here in this case, it's going to be this Studio storage. Also, existing service role to Studio service role. We'll also need to change the workspace settings to workspace 1. And the application settings as well. Okay. We'll say application 1 and also choose a runtime role as EMR Studio runtime role. These are the different settings in creation of the EMR Studio. Since I have already created one, so I'm going to cancel. However, if you'll be doing this for the very first time, you will select this Create Studio. I'll cancel this. The studio has already been created. It'll provide a studio access URL. Clicking here will take to the page just like this. Click on the workspaces, and we will already have a workspace by now based on the settings earlier. Clicking this workspace will launch a workspace something like this. Okay. The very first time you will not see anything, you will see the launcher. However, the workshop also provides a notebook for EMR basics. So you click on here, upload files. You browse to your location and point it to the file, and you will upload the file here, EMR Iceberg Basics Python notebook. This is a notebook environment. However, as we are accessing the code development, we need the compute environment as well. And here in this case, for the workshop, we are pointing this compute to the serverless application to make it simple. And this serverless application is attached to the workspace. Okay. When you are opening up this file, it will take you to the page just like this. What are we going to do in this basic functionality in EMR? A set of CRUD operations. If you want to make it in a very simple explanation, we're going to create an Iceberg table, read data from the table, update, delete. And in the fifth step, we are going to do a rollback and roll forward. And finally conclude the notebook with schema evolution and how it is different from a traditional database style architecture, right? And it's the Iceberg uniqueness as well. We'll be working on two tables. The prepared customer is for this basic functionality. Prepared web sales, we will use this data set for the advanced functionality. This data set is already pre-populated as a part of the workshop. However, you can still also refer back to the original version of the database and the table from this website, TPC data, the customer table, and the web sales. The customer table will have 2 million records, and the web sales have 72 million records. Okay. Now that we have this setup right now, couple of changes we need to make. The first one is in this particular self where the code is there to create a Iceberg catalog, we will have to make an edit here and point back to your account ID to make this location unique. If in doubt, go back to the original console page, click here, copy the account ID, come back and make it. When you will be opening up this notebook for the very first time, you will see a placeholder account ID, and that's where you will have to edit it. This is one place. And the second place where you have to modify the data is again in the second cell as well. These are the two places where you have to place your account information. And if in doubt, you can also go back to the S3 table, and here you will see this same information. This is the account ID as well. Okay. Once you place, I have already executed all the steps in the interest of time. However, if you can use Shift Enter to enter this, execute this code, or click on Run here as well. Okay. The first step here is creation of the Iceberg catalog. The second one is setting up certain environmental variables that we will be using in the further sections down below. Bucket name, as I mentioned, we are pointing to our S3 bucket. One thing to point out is when you are using the EMR serverless section of the base, the catalog that we will be creating, the database that we'll be creating attaches a word EMR underscore Iceberg database, the service name. When you will be using for glue in the next section, you will see glue underscore Iceberg underscore database. So that makes the database unique and the tables underneath as well. Okay, that's a nice way to segregate and make it in an isolated fashion. So I have executed this successfully. Here are some of the libraries that we need to import. Import Boto3, JSON, etc., etc. And as a part of the CRUD operation on the Iceberg table, we will be using some actions. And this notebook provides a convenient way that the function has been created for each and every action that we will be doing down below, the CRUD operations, etc. Right? So list files, printing files, show table files. Just make a note in your memory that we will be referring to this function and providing the table name to get some information about the tables, show data files, current metadata pointer, and so on and so forth. So this is one-stop place where all the functions have been defined and kept it for our future use. Okay. Now we are importing pandas here. Most of you as a data engineers must be familiar with this one. So I'm going to move down. By default, the current catalog points to the Spark catalog. We are just validating that this is showing a Spark catalog. However, in the very first step, we have created the Iceberg catalog. That's where we are going to access our data and the tables underneath this catalog. So we are going to use this, change it from Spark to Iceberg. Validating this current catalog now points to Iceberg. So it moved from Spark to Iceberg. Now the data that we saw, the customer data, the 2 million records are currently in the Spark catalog. We can still access the database and the tables information from in a different catalog. However, we need to specify the fully qualified namespace information. And that's what we are seeing here. The database information, there are 6 of them. This is the modified version, the customer and the web sales. As I mentioned, the customer information will be used in this base functionality validation. And for the advanced functionality, we will be using the web sales one. In this catalog, we are going to create the database using this Spark SQL command, create database. It ran successfully. And within this database, we are going to use the table creation, right? So these are the environment variables that was referenced in the second step of this notebook earlier. Okay. This table will have 5 columns as you are seeing here. Now the table has been created. Currently it is empty, but however, this is a table name and this is a database name here. Okay. This particular command provides description about the table. As we saw, there are 5 columns and then the metadata information about those columns and the table metadata as well. Okay. We are also seeing the table properties through this SQL command. This snapshot information will make sense when we come down below. Before going down to showing the other set, I just want to point out that this Iceberg table structure follows this 3 layers: the catalog layer, metadata, and the data. The catalog will point to the most recent metadata file. In this metadata layer, there are 2 components: metadata file, which has a collection of the snapshots, and the manifest list file, which points to one specific unique snapshot. As you are seeing here in this pointer, this list file is pointing to only snapshot 0, and this list file points to snapshot 1. And the manifest files will point back to the different data files individually. The manifest list file will also point to the list of all the manifest files. As you are seeing here, this list file can contain 1 or more manifest files, and this manifest file, each one will correspond to 1 data files. Okay. One thing to point out in a very summarized fashion is every operation here, there can be different kind of operation. Commit, roll back, roll forward, etc. creates a new metadata file, which means that it creates, if you're doing a commit operation, each one creates a metadata file, and anytime the new metadata file creates, the catalog will point to the most recent one. Okay. Here in this case, as we are moving forward from left to right, when there will be a metadata file created in the future, this catalog will point to that, not this one. So it always points to the most recent one. One other uniqueness we also want to point out is within the commit operation, which means that it can be an insert, update, or delete, will create a new snapshot. Okay. The rest of the operation will not create a snapshot. It will only create a new metadata file. Okay. Meaning those commits, the insert, update, delete, touches the actual data file, meaning we are creating something, we are updating something, we are deleting something, which means that this data file has been touched. So that creates the manifest and the snapshots, and that's why it's given here. Okay. Okay, now back to the table notebook. So we are seeing the short table files. When you're using this for the very first time, it will show differently, not this one. We'll just see a couple of only one metadata file. You can also access information like this. Go to the S3 table, workshop data, data sets. We are talking about EMR Iceberg, the catalog information, the table. And this consists of two folders, the metadata file, which will consist of all the metadata related information. One thing to also point in this juncture is whenever you see a file metadata.json, it always points to the metadata file here. Okay. And whenever you see a file that points to snap dash something, it points back to the manifest list file. Remember, we told the manifest list file will refer back to the snapshot. So snap dash something always means it is a manifest list file. And then the individual manifest files are referred here as M0, M1, etc. Okay. Just so that you keep that in mind here. This information, entire metadata information, is in the metadata folder, and also a separate data folder which consists of all the data changes that happened here. Okay. Now that we have this, we are seeing the current metadata file, which means that the most recent metadata file consists of the table with these 5 columns, schemas. The very first time we don't have any snapshot because this table is still empty. There is no snapshots created yet. And now this is a point where we are inserting the data. Up until this point, the table has been created. As I said, no data yet, right? Here, before inserting the data, we are just verifying one more time that from the Spark catalog, we are seeing the customer table, a sample of them, 5 columns, and the sample list. We are taking this information from the Spark catalog and inserting back into our Iceberg catalog and the Iceberg table. And there are 2 million records, as we pointed out. This information is just as I mentioned here, the metadata files is the file that is ending with metadata.json. Anything that's snap dash something will build the manifest list file. You can think of this manifest list file or the metadata information of the manifest files. And by this show table file, this is a function that you saw in the very second cell. And by giving that customer table name, it's printing back the root information and all the data and the metadata, which can also be accessed in this S3 table as well. Now that we have inserted the data, at this point, we would be seeing one snapshot, and also metadata pointer is pointing to the most recent one. If you think about it, this metadata, the JSON in the visual view will be this one, okay? Because the very first time. Later, after the steps, we will also be doing some other additional work, which means that new metadata file will be created. So just so that I want to correlate the information that we saw in the notebook back in the visual view, okay? Going back here, we inserted the data. Now querying the data. Querying the Iceberg table can come in two forms, like as we are seeing here in the Spark SQL form, also in the data frame API form as well. So both ways we can access the data, and Iceberg supports both of them. This is the SQL style that we have seen earlier up until now in the notebook. We are seeing a sample list of all the entries. From the data frame side, we're also seeing the similar information or the same information. Now, continuing on with the CRUD operation, we are updating the record. Here before updating, we are just validating one customer record entry with the identifier 15. We are seeing that there is no last name or the email address. And this is where we are going to update the records. In this update statement, we are setting the last name here and the email address to this. And this cell, we are validating again what we have changed, right? So the last name has been changed from nothing to John, and the email address from nothing to this abx.com. This update also results in the new data file, as you are seeing here in the insert at the insert time. The 209 time frame, we are seeing the one data file, and after updating, we have seen a different data file pointing to the most recent timestamp. Now that we have updated it, we are going to delete it. What we are going to delete is the same entry that we got updated. Delete from where the identifier equal to 15, and so the data has been deleted. Okay. Now this resulted in the third data file, which means that this most recent one as of 214, the data that we have currently will have all the entries except the customer ID underscore SK equal to 15. Okay. This is the very first set of data which is inserted. This is the updated one where the customer email and the last name has been updated for SK equal to 15. And here the deletion. Okay. Up until now, again, referring back, we have completed all the CRUD operations. Now, the second category is time travel and rollback. This is a quick preview of all the metadata information here. The snapshots, manifest list file will point to the snapshot as I mentioned, right? And here, in a traditional database sense, we would have lost the data permanently, right? However, using Iceberg tables rollback and roll forward, we are able to go back in time and able to recover in case of inadvertent data loss. Before that, we are just doing a quick status. This first line item is the parent, which is a data insertion the very first time. So that created a snapshot. Because this is the first one, there's no parent ID. Next, we made some updates that created a new snapshot ID as you're seeing here. And this is referring back to the old one as the parent. The third scenario is where we have deleted the data. This deletion is based on the previous snapshot, and so this one is pointing back to this. This points back to this. Okay. So we can go back in time by using this snapshot IDs. Okay. Here is a quick code to extract the two snapshot IDs, the most recent one, the second, and the latest one. Using this information, we can get the data, which means the select star from this table as of this snapshot ID, right? The second snapshot ID points back to this. And in this case, if you still recollect and following, we have updated the last name and the email address. In the third snapshot, we would have lost that information, right? And here is where we are seeing the data files, again, 3 of the data files that we saw earlier. Now, we are going to roll forward. We are going to say update this information with the latest snapshot ID, which means that we have removed that ID again. Okay. So we are rollback, meaning from here, we have come back to this one, this snapshot ID, where we have here in this situation, we have deleted the data for SK equal to 15. However, we have rolled back to this original situation where we now have that info, the entry, okay, with the last name and the email address. So this is what, and this parent ID is again referring back to the original one, okay. So this table file again, the standard function going back to the root location and all the data and the metadata information. Schema evolution. In a traditional sense, once the structure has been created on a database, changing the column information is a cumbersome process and without impacting the data, right? Which means that either renaming the column, moving the column, or adding. Here in this following steps, you'll be able to see that Iceberg allows it to have it much easier without having to touch the data. As you might know from now, we have 5 columns and the last column is the email address. In the 2 variations of schema evolution, the first one we are going to see that we are going to change the column name to a different one from email address to email, and that can be considered with the alter table command. Now selecting a sample list of data information, you are seeing that this information has been updated. However, the data has not been touched yet. So that's the uniqueness of the Iceberg table, because we have the different layers abstracted. Whatever change that we are making at the schema level is only at the metadata layer, not at the data layer. Okay. To confirm that, we are seeing that data file has not created a new data file, which means that it still continues to have the old set of data. However, the metadata file has changed, telling that this is the first one, which had the old column name, to this new column name. Okay. And the second variation of the schema evolution is to add a new column here, adding a column with the birth date information and the integer type. Now, when we are executing this select statement for 10 rows, we are seeing that the new column has been added. Again, the data has not been touched yet, anything. We still continue to have the new modified column name. Okay. So these are the 2 variations of the schema evolution, the renaming of the column and then adding a new column by itself. Okay. So that brings down to all the steps as outlined in the workshop for EMR serverless on open table format. Just a quick summary on the data sets in the data S3 tables. We start with the workshop data, EMR Iceberg. This is the name that we have given, database name, the table information, and that consists of 2 folders. All the variations that we have done for CRUD operation, rollback, roll forward, etc., as captured in these 3 sets of files, the metadata JSON, and then the snap dash, the numbers is a manifest list file, and the ones with the dash m number is the manifest files. And one level above is the data files, okay, for insert, update, and delete operations. Now, in the continuation of this, for glue, if you follow the steps, you will actually create a glue notebook, upload the glue notebook as outlined in the workshop. The very similar structure as you were seeing from the EMR serverless, except that we are executing everything from the glue Spark session. Instead of going from complete top down, I just want to give a glimpse of a sample here. As we have updated the account name in this first cell here, and also in the third one here as well. Here are the 2 places where you have to update when you're going through the workshop. However, the rest of them is completely identical, right? I executed a set of steps here, like down below. If you recollect, we started with the default Spark catalog, then changed to Iceberg catalog, validated it, and the tables available in the Spark catalog, the customer and the web sales, everything is identical except that the environment that we are executing this notebook is in Glue and not in EMRs. Okay. Again, if I start going down completely, then it would become a repetitive one. But since we have completed everything in the EMR serverless, you will be able to complete in Glue without any issues. Okay. Now going back to this slides. Here are the 2 quick references that I wanted to share. The first one is the open data on AWS workshop. Here is a QR code. If you're interested in this topic and want to get to know more about the Apache Iceberg open table format, and here's the documentation as well. I thank you for your time and joining me in this first part series of the open tables on AWS. I hope to see you on the next session. Thank you so much. Bye.